Example 5, determine any vertical asymptotes, points of discontinuity, and intercepts for this equation. So what we're going to do is I need to factor this equation first so I can see what my non-permissible values are in the denominator. And we also want to see if anything will cancel. So when we factor this, we're going to get x minus 5, x plus 3. Here we're going to get x minus 4, x plus 3. And you'll see that the x plus 3's cancel. So let's write our new equation out. It's y equals x minus 5 over x minus 4, where x cannot equal 4 and negative 3. You must include these restrictions in your equation answer. Otherwise, you wouldn't even realize, particularly the negative 3 non-permissible value. It's these NPVs that are going to help us with the vertical asymptote and the point of discontinuity. So the the binomial that remains in the denominator that didn't cancel out is going to determine my non-permissible value for the vertical asymptote. So you're going to have a vertical asymptote at x equals 4. The point of discontinuity is going to be linked to the one that was canceled out, so the negative 3. So the point of discontinuity is at x equals negative 3. Now, because it's a point, you need to find the y value. So you're going to need to find the y value by plugging in this negative 3 in for x. So negative 3 minus 5 over negative 3 minus 4 equals negative 8 over negative 7 equals 8 over 7. So your point, so the actual answer to this is negative 3, 8 over 7 in brackets. Okay, so you need to make sure you write that as an ordered pair. All right, let's talk about the intercepts. We're going to start with the y-intercept. So for the y-intercept, you're going to just plug in 0 for x. So we're going to do that in our original equation here. So we get y equals 0 squared minus 2 times 0 minus 15 over 0 squared minus 0 minus 12. So you get 15 over 12, which reduces to 5 over 4. So then you might be wondering, well, did I have to use the original one or could I have used the simplified version? Well, let's have a quick look. If you plugged in 0 into the x value for your simplified equation here, you do get the same answer, and it was actually a little easier, a little less work to come up with that. So it is a good idea then, and I kind of circled this one, to use a simplified answer. That works just fine. You'll notice that really it's the constant term divided by the constant term, which works in both of these cases. So let's look at the x-intercept. We're going to do the same thing. Let's use the original question and we'll compare it with the other one as well. So for the original question, we're going to put 0 in for x squared minus 2x minus 15 over x squared minus x minus 12. So when I cross multiply, 0 times this denominator is going to equal to 0, and we're left with 0 equals x squared minus 2x minus 15. Because remember, this would be times 1. You've got your quadratic, so of course we've already factored this above, so we're just going to write this in factored form now. So x equals 5 and x equals negative 3. But you have to remember, x equals negative 3 was one of your restrictions here. So this is actually not one of the x-intercepts, so your x-intercept is 5. Well, what would have happened had we then used the the simplified equation? And we plugged in, I was going to just rewrite out the equation first here. So had we done this and we plugged in 0, and when we cross multiply, we get 0 equals x minus 5, and we would have had x equals 5 only right away. So once again, it's actually going to be smarter or efficient to use the simplified equation, and then you don't have to worry about, coming up with that NPV, because of course it had canceled out in this equation. So of course that's why it's your NPV, and that's why it's not going to be one of your x-intercepts. So if you're really looking at this, the 0 of what remains in the numerator will end up being your x-intercept each time.